In this lesson, we're going to look at how we can find the inverses of rational functions. So first we're going to find the inverses, and then we'll identify the domain and range, and then determine if functions are inverses. So the first thing we're going to do is do an inverse recap. So we talked about inverses before in a previous unit. So there's a couple of ways we can find the inverses. Algebraically, if we're trying to find the inverse, we're just switching the x and y. So that could be in terms of points. So if I have the point 2, 1, the inverse of that would be 1, 2. When I'm solving an equation, I'm actually going to switch the x and y, and we'll talk about that when we go through the examples. Graphically, what an inverse is a reflection over the line y equals x. So here you can see that the darker blue line is the original function, and this teal blue line is the inverse function. And basically, they can, if you fold them over the line y equals x, they will match up and overlap. So it's just a reflection over the line y equals x. The domain of the original function becomes the range of the inverse and vice versa. And we can determine if two functions are inverses by using composition. So that's when we do that f of g of x and g of f of x. And we have to check it both ways. And if we get x as our answer, then they are inverses. So the steps to solve for the inverse, now this is true for any inverse that you're solving. The first thing you want to do is replace f of x with y. And it could be f of x or g of x, or any type of other letter with x. Then we want to switch the x's and the y's in the function, and then we solve the equation for y. And then once we have the equation that's set up as y equals, we'll replace the y with f inverse, or if we're using g inverse. Okay, so let's put this into practice here. So first example, find the inverse of f of x equals x plus 5 over x minus 5. Then identify the domain and range of both functions. So the first thing I'm going to do here is I'm going to replace the f of x with y. So I'll say that y is equal to x plus 5 over x minus 5. After I do that, I will now switch the x's and the y's. So instead of the y here, I will have x equals, and then instead of these x's, I'll have y. So y plus 5 over y minus 5. Okay, so our goal here is to get y by itself. We want to get y equals. So in order to get the y by itself, the first thing we'll have to do here is get rid of the denominator. So by multiplying both sides by the denominator, I can cancel it out. So I'm going to multiply the right side by y minus 5 and the left side by y minus 5. Okay. On the right side, these will cancel out. On the left side, I want to make sure that I distribute. So I'm going to distribute the x to the y and the x to the negative 5. So x times y is going to give us xy. X times negative 5 is going to give us negative 5x. And that is equal to y plus 5. So now we just have one line of our equation. And now we want to get the y's together. So in order to get the y's together, I'm going to subtract the y and bring it over on this side. And I'm going to move this negative 5x to the other side by adding the 5x. Okay, so we're just kind of flip-flopping things around. So on this, these will cancel out and these will cancel out. So on the left-hand side, we have xy minus y. On the right-hand side, we have 5x plus 5. Okay, so we're almost there. What we want to do now is factor out the y. So looking at the left-hand side, what they have in common is a y. So we can take out that GCF of y, and then we'll be left with x minus 1 equals 5x plus 5. And then lastly, to get y alone, we're going to divide both sides by x minus 1. So we end up, these will cancel out, we end up getting y equals 5x plus 5 over x minus 1. And our last step is just to change the y to f inverse. So we're going to say f inverse of x is equal to 5x plus 5 over x minus 1. And this would be my inverse function. Okay, so now we're going to find the domain and range. So when finding the inverses, it's easy to find the domain and range by finding the inverse of the original. So let's just look at the original first. The original function is the x plus 5 over x minus 5. So the domain for this, let me change colors here. The domain for this one would be all real numbers, except x cannot equal 5. Right? And we know that because whatever makes the denominator 0 is going to be our restriction. For our range, we can see that it would be all real numbers, except y can't equal our horizontal asymptote. Because the degrees are the same, we can divide what's in front, so y can't equal 1. Now, finding the range is sometimes a little bit tricky. So if we find the inverse, we know that the domain and range of the original will be the reverse of the inverse. So for instance, the domain of the original should match with the range of the inverse. Okay, so let's just focus on this inverse now. Let's look at this one. If I were to find the domain and range from here, the domain would be all real numbers, except x cannot equal 1. Now, if we notice, that's the same as the range from the original. So even though the range is in terms of y and the domain is in terms of x, the actual number that is the restriction is going to be the same. Okay, so based off of that logic, we can assume that the range for this inverse will have a restriction that it can't be 5. And let's just double check. So the range here would be all real numbers, except y cannot equal the horizontal asymptote. Again, your degrees are the same on the top and the bottom. So if we were to divide what's in front, 5 over 1, we get 5. So here, the domain of the original matches with the range of the inverse, and the range of the original matches with the domain of the inverse. So for the problems that are a little bit difficult to find the range, if we just find the domain of the inverse, that will help us find the range. Okay, so let's look at another one. Actually, here's the graph. Let's look at these real quick. So this graph on the top left here, this red graph, this is the graph of f of x. This blue graph is the graph of the inverse. And you can see that if I were to draw a line of y equals x, if I were to reflect this red image over this line, it turns into this blue. So this down here is just showing both at the same time, and the green line, or the green dotted line, is the y equals x reflection line. So you can see that how the original function and the inverse kind of look. They're going to look similar, and again, they're just reflections over the line y equals x. Okay, so let's look at this other example here. Okay, so same thing as before. So we're going to find the inverse first. So first thing I will do is make this y equals 2x plus 7 over 3x minus 1. I'm going to change the y's to x and the x to y. So x equals 2y plus 7 over 3y minus 1. Okay, we want to get rid of the denominator, so we're going to multiply both sides by 3y minus 1. So these will cancel out. We're going to distribute the x. So this is going to give us 3xy minus x, and that's equal to 2y plus 7. Okay, we want to get all of the y's on the same side and anything that's not a y on the other side. So we're going to subtract the 2y to this side, and we're going to add the x to this side. Okay. So what we have now is 3xy minus 2y equals x plus 7. Okay, from here, we can factor out the GCF, which is y. So we'll get 3x minus 2 equals x plus 7. And then to get y alone, we'll divide by 3x minus 2. So these cancel out now. So our inverse, so we have y equals x plus 7 over 3x minus 2. And we're just going to change the y to be the inverse of f. So inverse of f is equal to x plus 7 over 3x minus 2. Okay, so let's find the domain and range of each. So what I'm going to do in this case right now is just find the domains of both. And once I know the domains, I can find the ranges based off of it being the opposite. So if I look at the original function, I know that the domain will be all real numbers, except x cannot equal what makes the denominator 0, which in this case would be 1/3. Okay, now let's take the domain of the inverse function. So if I'm looking at the inverse function, the domain would be all real numbers, except x cannot equal what makes the denominator 0, which would be 2/3. Okay, because we know the domain of both, we can find the ranges very easily. The range of the original is going to be the domain of the inverse. So all real numbers, but because it's range, we're going to use y. So y cannot equal 2/3. And the range of the inverse is going to match the domain of the original. So the range would be all real numbers. Again, we're using y instead of x. And it was 1/3, so this will be 1/3. Right? And we can also use the horizontal asymptote, just kind of like double check here. And we can see that the horizontal asymptote for the original function is 2/3, so that's my restriction. And the horizontal asymptote for the inverse is 1/3, and that's the restriction. Okay. So let's look at this one now. This one's a little bit different. So it looks a little bit different because we have this -5 outside of this fraction. So we're going to follow the same exact steps. We're going to make this f of x equal to into a y. So y equals 1/x plus 3 minus 5. Okay, just like before, we're going to switch all of the x's and y's. So x equals 1/y plus 3 minus 5. Okay, now before I get rid of the y plus 3 in the denominator, I need to move this -5. So what I'm going to do here is I'm going to add 5 and add 5. Okay, so these 5's will cancel. So now we have x plus 5 equals 1/y plus 3. Okay, now we can get rid of that denominator by multiplying both sides by y plus 3. So these will cancel. We have to multiply y plus 3 on this side. Okay, so here we have to FOIL. So we're going to do y times x. So I'm just going to call it xy. Y times 5. That's going to give us 5y. 3 times x. So that's 3x. And 3 times 5, which is going to give us 15. And that's going to be equal to 1. So just like before, we want to make sure we get all of the y's on the same side and anything else that's not a y on the other side. So what I'm going to do is just subtract the 3x and the 15. So minus 3x and minus 15. So on the left-hand side here, we have xy plus 5y. On the right-hand side, we have negative 3x, and then we have the 1 minus 15. So I'm going to get negative 14. Okay, so just like before, we're going to factor out the GCF of y here. So we get x plus 5 equals negative 3x minus 14. And then we're just going to divide both sides by x plus 5 to get y alone. So we'll get y equals negative 3x minus 14 over x plus 5. And then our final step, as usual, is to replace the y with f inverse. So f inverse of x is equal to negative 3x minus 14 over x plus 5. Okay. Now here is where it's useful to know how to do the inverse in order to get the range. If we look at the original function and we find the domain of the original function, the domain will be all real numbers, except x cannot equal whatever will make the denominator 0, which is negative 3. Okay. For the range on this one, it's a little bit tricky because there's some other stuff going on. So again, let's focus on the inverse. If I take the inverse and I find the domain, all real numbers, x cannot equal what makes the denominator 0, which would be negative 5. So my range, therefore, of the original will be all real numbers, except y cannot equal negative 5. And then my range for the inverse is based off of the domain of the original. So all real numbers, except y cannot equal negative 3. And there we have our domain and range. Okay, and then the last thing we're going to look at is how to determine if two functions are inverses of each other. So we've done this before with composition, But now we have composition with rationals. So we're kind of bringing back in those complex fractions. So this is kind of a good review of everything that we've already done. So I need to check f of g of x. So we're going to check this one first. So this is that composition, and what we're doing is we're plugging the g of x function into the f function. So actually, let me change this color so it's a little bit easier to understand. So let's do g of x in red. Okay, so remember that the outer function is what we're gonna write, and anytime that we have an x, we're gonna leave it blank. So this is going to be 7 blank plus 1 over negative blank plus 9. Okay, and in those blanks, I'm putting in the g function. So I'm going to put in 9x minus 1 over x plus 7. And again, 9x minus 1 over x plus 7. Okay, so we want to solve this. And if we can get x, we're going to check the other way around and see if we get x also. And if they both equal x, then they're inverses. So this is a complex fraction. So we've seen this already in this chapter. In order to simplify this, again, you can do the top separately and the bottom separately if you prefer. I'm going to look at everything overall, and I'm going to multiply the entire thing by the common denominator, which is x plus 7. So I'm going to multiply this 7 times 9x minus 1 over x plus 7 times x plus 7. The x plus 7s will cancel out, so I'm going to have 7 times 9x minus 1. And then I have this 1 has a denominator of 1. So when I multiply it by the x plus 7, I'm going to get 1 times x plus 7. Okay, so that's the numerator. And then on the denominator, the same idea. The x plus 7 is going to cancel with this x plus 7. So I have a negative 9x minus 1. And then this 9, I have to multiply by x plus 7. So we'll just say it's 9 times x plus 7. Okay, so we want to make sure that we distribute all this. So if I distribute, we're going to get 63x. That's 7 times 9x. Then we're going to get minus 7. Then we're going to get plus x. And then we're going to get plus 7. In the denominator, distribute the negative. So we'll get negative 9x plus 1. And then plus 9x plus 63. Okay, so if we go to simplify this negative 7 and the positive 7, these are going to cancel out. So 63x plus x, that's going to be 64x. On the bottom, the negative 9x and the positive 9x will cancel out. 1 plus 63 is 64. If I divide 64 and 64, this equals x. Okay, so we got x. Now we want to check this the other way. So we're going to do g of f of x. So the same thing we just did pretty much, but the opposite way. So we're going to write the g function. So let me just separate this for a second so we don't get super confused. Okay, we're going to write the g function and leave spaces wherever we have an x. So we're going to have 9 space minus 1 over blank plus 7. Okay, and in those blanks, in those spaces, we're going to put the f function. So 7x plus 1 over negative x plus 9. 7x plus 1 over negative x plus 9. Okay, and just like before, what we're going to do here is multiply the entire fraction by that common denominator. In this case, that common denominator is negative x plus 9. Okay, so what we're going to do again is just, let me change some colors here. Yeah, let's do that one. Okay, so I'm going to multiply this negative x plus 9 to this first fraction, which will cancel with the negative x plus 9 in the bottom here. So we're going to have 9 times 7x plus 1. And then here, the negative 1, we have to multiply to the negative x plus 9. So we'll have negative 1 times negative x plus 9 over, and then same thing on the bottom. Negative x plus 9 is going to cancel with the negative x plus 9 in the bottom here. So we'll just have 7x plus 1. And then negative x plus 9 times the 7, we're going to have 7 times negative x plus 9. And then lastly, we're just going to try to simplify this a little bit. Oops, let me change it to this color. Okay, so we're going to distribute. 9 times 7x is going to give us 63x. 9 times 1 is going to give us 9. Negative 1 times negative x is going to be positive x. Negative 1 times 9 is going to be negative 9. In the denominator, we have 7x plus 1, and then we're adding the 7 times the negative x, so negative 7x. 7 times 9, 63. So again, look at the top here. We've got the 9 and the negative 9 will cancel. So 63x plus x is 64x. In the denominator, the 7x and the negative 7x cancel. So we have 1 plus 63, which is 64. When we divide 64x by 64, again, we're getting x. Okay? Because we got x for both iterations of f of g of x and g of f of x, we know that these are inverses. So we can say, yes, they are inverses. And that is because they both equal x when we did composition. Okay, so for homework, you guys are going to try these 4 problems. The top 3, you're just going to find the inverse of the function and identify the domain and range of the original and the inverse. So like those first 3 problems. And then for problem 4, you have 2 functions and you're going to use composition, both f of g of x and g of f of x, in order to determine if they're inverses of each other.